Welcome back to the 8th video of this series. I'm Aaron Nightingale, owner of Nightingale LED Solutions and co-owner of the LED Costume Academy. I have over 10 years experience in wearable technology and soldering on the Las Vegas Strip. Hopefully you've watched the other videos of the series, and don't forget to hit that like button and subscribe for upcoming videos. And please feel free to comment to help others learn. Today we will be looking at LED strip, how to set up a simple dumb pixel LED system, as well as how to solder LEDs to extend or repair the strip. These are the types that you'd most likely buy online and control with a remote to add some color to your room, or single white color to highlight a bookcase or under cabinet. One of the most misconceptions about this type of strip is that people want it to chase, but with these strips, when you change the color, the whole thing changes together. There are more sophisticated control options that you can upgrade to, including DMX decoders for use in stage and movies. You can get these LED strips, a power supply, and IR or RF controller that will start at around $10. Many now come with an app to allow you to connect to Wi-Fi or Bluetooth. LED strip comes in many chip sizes, with common ones being 50/50 or 35/28. With the numbers representing millimeters. So 35/28 is 3.5 millimeters by 2.8 millimeters, and 50/50 is 5 millimeters by 5 millimeters. There are also COB chip on board LED strips that are represented by number of LEDs per foot or meter. There's many color options with various Kelvin of white, from very white or amber to cool or blue, and color mixing in between, with the lower number being the warmer temperature. Weatherproofing electronics in LED strip are expressed as IP, or ingress protection rating. The IP will be noted as 2 digits. The first digit being its level of protection against solid objects, such as number 2, fingers, 3, tools, 5, dust or sand for 2 to 8 hours, and 6 being subject to dust for 8 or more hours. The second digit is level of protection against liquid, in 0 being none, 1 being large drops, all the way up to 4 being a splash, 5 being a spray jet, 6 a heavy spray jet, or C's, and 7 being fully immersed in water for up to 30 minutes. 8 would be in liquid for extended periods, such as a pond or a tank. For instance, the rating of this non-coated LED strip is ingress protected with a rating of 20. The strip with the silicone covering just on the top is IP65. And this strip, encased in a silicone sleeve, is IP68. Let us start with the initial setup of an LED strip. These should come out of the box, very plug and play. The power supply plugs into the controller with this little barrel jack. The strip plugs into the controller via the 4-pin connector. You'll see a small arrow on each connector that indicates the power. These will need to line up for your strip to work. I'm not a fan of these strips, or these connectors, as they don't lock in. So first troubleshooting should be making sure they're seated together and the arrows line up. So plug in, aim the remote, and turn on the strip. Now if the strip turns on in different colors than you were pushing, it means the remote needs to be reconfigured. In this case, red comes on green, green comes on red, and blue comes on blue. This is a simple process, and doesn't matter if you have the 24 or 44 key remote. Turn off the strip with the remote, aim the remote, and press the bottom right button. On the 24 key remote, it's smooth. And on the 44 key remote, this one is fade 7. The strip should blink. Turn on the strip and check again. If it's still not correct, repeat the process. Turn off. Bottom right flash. Turn on. Red, green, blue. You may have to repeat this process several times until it becomes correct. So say we want to extend the wires to a different shelf. This is very simple to solder after a little practice. I'll be using this pre-made 4-color wire. Black is power, green, red, and blue are the respective colors. Okay, so we now have our strip working. We want to extend the wires to a different shelf. This is very simple to solder after a little practice. Start by stripping 1/16 to 1/8 of an inch from your wire. I'll be using 22 gauge 4 wire, which is color coded. Black or white for power, depending on your manufacturer. Green, red, and blue for the negatives, in that order. Some manufacturers will have a different order, so make sure to double check on your strip. It'll say plus for power, GRB, or any version of that. Strip the wire. And repeat on the other side. All right, we want to pre-tin our pads. Each strip will indicate where it can be cut. There's a printed cut line, and the strip needs to be cut on this line. If you cut in the middle of a strip, that section will not work. Because we're using IP65, we need to peel back the silicone to expose the solder pads, as I've already done here. This can be done with your fingernail or a sharp blade, but be careful not to cut the pad or yourself. Cut the silicone off just past the solder pad. Sometimes a residue is left that prevents the solder from flowing to the pad. You may need to scrape off a little with a blade tip or some light sandpaper. We'll tin both our wires and the solder pads. A smaller tip is helpful for this to prevent creating a solder bridge between pads. If you do create a bridge, it's not a problem. There are several easy fixes. If you have a solder pump, you can heat the solder and remove it with this suction. Another method is to just scrape and clean the pad with your iron tip. You'll need to scrape and clean your tip a few times, but this method does work. One thing to consider during splicing is the makeup of the strip. Extreme heat can melt the plastic and separate the copper strips, leading to tearing the solder pad off. This should happen less and less with practice, but it still happens to me, especially if I'm soldering in a tight space during a repair or installation, or if my temperature is set too high. Don't forget to put your heat shrink on at this point. I put the heat shrink on after tinning to prevent heating the shrink tube prematurely and shrinking it before I finish soldering. Set the soldering iron on the pad, and it should turn liquid after a second. Place the wire, let it cool, and we'll move down the row. And we'll repeat on the other strip. Inspect and clean the finished joint. Pull heat shrink over the finished splice and heat if necessary. You can add silicone as well to make water resistant again, or use an adhesive lined or marine grade shrink tube. Let's say that one of the solder pads ripped off. We therefore need to conduct a repair. I will show you two different methods. After a little practice, and depending on the circumstances, you can select which of these two methods to the one that suits your needs best. It's also possible that one of the LEDs in the segment got wet or damaged, or both. We'll start by soldering the strips directly together. Cut back the segment with the damaged pixel. I like to leave a full solder pad, cutting just past the cut mark, giving me a little extra room to solder. Peel back the silicone. We'll take our replacement strip, again peeling back silicone, and on this one we'll also peel off the adhesive layer on the bottom, exposing the pads there. You might need to use a blade as well for this. And again, tin the pads. Now we're also going to tin the pads on the bottom of the strip that we just did. Line up the cut marks and heat the full pad on the bottom. And then transfer to the top of the replacement strip. This will create a solder bridge. And repeat for the second one. You also want to make sure that your positive and negatives or any colors line up and you're repairing with a similar style strip. The second method is using copper tape. This tape comes in various thicknesses from less than a millimeter to several inches. Cut both sides of the strip back and trim off any silicone. Lay the cut marks together until they're just touching and tin your pads. Peel off the back. And cut if needed. Lay the cut marks together. Tape across both pads. And apply heat to melt the solder. Inspect and test. And ideally this would be going in a raceway or somewhere that's already protected. But you may need to add silicone or heat shrink as required. Trim off any excess wires. Thank you for joining me, and I look forward to seeing you in my next videos. Please check out theledcostumeacademy.com to learn more about power supplies, controllers, smart pixels, and adding LEDs to wearables.